Today we're looking at proper form of scientific notation. Very often as we look at scientific notation, sometimes this expression here, times a power of 10, is enough to confuse kids to thinking that they're doing scientific notation. However, scientific notation takes special form. And as it takes special form, we want to make sure we use that special form. So let's go ahead and get down to it. Now this problem has already been turned into a multiplication problem by multiplying by a power of 10, which is a great start. But we need to learn, yeah, I'm stuttering a little bit there, sorry about that. We need to learn how to get it into that proper form. Now proper form demands one of these bad boys, that little black dot known as a decimal. And that decimal, as we learned, is always going to go right after our first whole number digit. So as we look at this, we need a decimal that looks like this. And of course, we're going to multiply by a power of 10. Now at this point, we need to realize what number we're dealing with. We can do this in one of two ways. We can do it the long way, and I'll show you how to do that. We take the number, right, 4600, and we actually multiply by 10 to the 5th power. 10 to the 5th power, of course, adds 5 more zeros. 1, 2, 3, 4, 5. And so we get this number here like this, 460 million. From here, then, of course, you could break it down, throw your decimal point in there and count backwards, right? 1, 2, 3, 4, 5, 6, 7, 8. And say, all right, 10 to the 8th. And you will have correctly solved that problem. But multiplying by these large numbers is something we don't really need to do. Instead, we can break down the error and figure out from there. All right? So if we take this number and turn just this number into proper scientific notation, we would have 4.6 times 10 to the 1, 2, 3. Right? And then, of course, we're still multiplying by 10 to the 5th. So we got our decimal number. That's good. But now we just need to join our powers of 10. And as we've learned, when it comes to multiplying exponents, we're going to leave the base the same, and we're going to take our first one, I'm going to change colors, our 3, and we're going to add it to our 5. 3 plus 5 equals 8. And so, as you look at this, we've taken two processes to understand how to get to 4.6 times 10 to the 8th. This one, of course, is a little bit longer, because you're filling out a bunch of zeros. This one here is a little bit simpler as you work with this, and eventually you'll get to a point where you can take this number right here. You can say, okay, right now the decimal's right here. I need it over 1, 2, 3, so let's put the decimal there and add 3. That would be the fast method. All right? So we'd say this is introductory, understanding it. This is breaking it down, and this is fast math. Take it at the pace you need. Here we go. All right, let's break down this number then. Now we got 10 to the negative 5th. As we look at negative 5th, it's suddenly we want to think number line, and we want to think 0, and we want to think negative 1, negative 2, negative 3, negative 4, negative 5. But quickly we need to say that no, that is not the mistake we want to make, because this wonderful negative 5 here does not mean the opposite side of the number line. As you looked at this earlier this year, a negative exponent such as negative 5 is really talking about the inverse, right? Take this number here and make it an inverse. Put it over 1. And so really what we're looking at here, a negative 10 to the negative 5th, is really talking about 1 over 10 to the negative 5th, or 1/100th. A decimal. A decimal number, not a negative number. So with that in mind, we would say, okay, let's put this in correct scientific notation. All right. Let's take this number and put it in the correct scientific notation. Now that we understand this idea correctly, we of course are going to move our decimal from here to here. Move it over one place. So we would say 25 times 10, sorry, 2.5, excuse me, times 10 to the first, times 10 to the negative fifth. We could break it down in that way. That's how we're putting in proper scientific form. Now with that in mind, right, we're multiplying exponents, which means we're going to add this. Let me change colors to make that clear. We're going to add this to this. So 1 plus negative 5. And of course, we've just spent a good amount of time adding and subtracting integers. And so we would know that that means negative 4. So in the end, we would say is our final answer. Or, as we mentioned earlier, right, we would say move it over 1, which means we got to add 1 because we went to the left. Went to the left. Right? Okay. We have that example. All right, we're cruising right along. All right, it's your turn now. Your turn now to put this into proper scientific notation. Best of luck to you, though you don't need it, because you're a highly capable person. You're working your best, and if you make a mistake, don't worry. We got you covered. We'll be right there, helping you realize what needs to be fixed, and of course, getting that done. All right, go get her done. Lesson 69.